Hello everyone, welcome back to my YouTube channel. Today we are going to discuss about RNS configuration, which is basically used to give configuration or to assign configuration to molecules containing chiral carbons. RNS configuration means rectus and sinister configuration, where R rectus means rotation towards the right side, while the word S means sinister or rotation towards the left side. This configuration is basically used to study or to identify the arrangement or orientation of atoms and groups attached to the chiral carbon center. What is the position of different groups such as OH group, maybe NH2 group or H atom connected to the chiral carbon center. This configuration was given by R.S. Chan, C. Ingold and V. Prolog, and therefore it is popularly known as Chan, Ingold and Prolog or CIP configuration system. It was given in the year 1966. R, as I said, it means rotation towards right side, means a clockwise direction, and if the direction is anti-clockwise, it reflects S or sinister configuration. Now before understanding or before doing certain problems related to RNS configuration, we must go through the rules for assigning RNS configurations. The first rule states that whenever we have a chiral center present in a molecule, we always put a asterisk to show that it is a chiral carbon center. So, since it is a chiral carbon, it is attached to four different groups. In this, I am giving four hypothetical alphabets A, B, C, and D, which are connected with this chiral carbon, and all these groups have different atomic number. Let's suppose A is having the highest atomic number, followed by B, C, and D is having the lowest atomic number. Now on the basis of their atomic numbers, we'll give them priority order numbers, which means that A, which is having the highest atomic number, will be given the priority order number 1, followed by B, then we have C, and D, because it is having the lowest atomic number, it will be given the priority order number 4. The first step or the first point is to remember that we have to give priority order number to all the groups or atoms attached to the chiral center on the basis of their atomic number. Once it is done, we will draw a line from 1, 2 and 3, irrespective where of 4, we just draw a line from 1, 2 and 3, and if this line is if this line is clockwise, we call it as R, and if the direction of this line is anti-clockwise, we call the molecule configuration as S. But this is not as simple as I said, because in most of the cases the student struggle to give priority order numbers, and therefore understanding the rule for giving priority order number is a very crucial step in learning the RNS configuration system. Priority, as I said, the first rule is to assign priority order number on the basis of their atomic number. Hydrogen present, since it is having the lowest atomic number, it is always given the priority order number 4, always hydrogen. Now when I said that a line has to be drawn from 1 to 3, I didn't mention about the group with priority order number 4, but it has a very important role to play. The priority order number 4 group basically defines the direction from which the molecule has to be viewed. For example, the rule says that the priority order number group 4 should always be point away from the viewer. For example, if this is a viewer who is looking at this molecule, then the molecule is having, for example, this is the tetrahedral shape of chiral carbon and it has different groups. So the group with priority order number 4 should always be away from the viewer, and if in case the group is coming towards the viewer, then we have to revert the configuration. For example, in that case, if the answer is R, we will assign S, and if the answer is S, we will assign R. As in this example, you can clearly see that this is the chiral carbon center, and there are four groups: Br, hydrogen, CH3 and oxygen. On the basis of atomic number, as we know that Br is having the highest atomic number, so we'll give periodic order number 1 to Br. It is correctly written here. Then among the left groups which are remaining, hydrogen, CH3 and O. O is having the highest atomic number because the group is attached through the oxygen atom. Here the group is attached through carbon, and carbon is having atomic number 6 while oxygen is having 8. So the group priority order number 2 will be given to oxygen. Then we'll give 3 to CH3 and then 4 because hydrogen is having the lowest atomic number. It is always given the priority order number 4. And this dotted line also shows that hydrogen is going away from the viewer. So as we are looking from the screen, the hydrogen is going away from us. Now sometimes, as I said, students struggle to assign priority order numbers, and in that case we have to follow certain rules. For example, in the present case there are two groups shown, and if this group attached to the chiral carbon, for example there is a chiral carbon attached over here and there is a chiral carbon attached over here, and these two groups are attached to that chiral carbon. Now in both these groups we can see that the chiral carbon is directly attached to carbon. Here also the chiral carbon is directly attached to carbon. Then to which group we will give higher priority number, whether this one or this one. So if the first atom through which the group is attached to chiral carbon are same, as in this case both are carbon, we'll go for the second atom. Then if we look at the second atom, we have CH3 on this side, also here we have CH3, again the groups are same. Then we look for the third atom. Here we have Br, and while in this case we have CH3, and since Br is having higher atomic number, so this automatically shows that this group will be given the higher priority as compared to this group. So I can put this sign which shows that the higher priority will be given to this group. Clear? Now in certain other cases, for example we have two groups. Here also we have carbon which is attached to chiral carbon, and this carbon is in the form of methyl group, and on the other side we have ethyl group connected to the chiral carbon. So first of all, as per rule, we will see the atom through which this group is attached to chiral carbon. Here it is carbon, again here it is carbon. Then we'll go look for other atom. Here it is hydrogen, here also it is hydrogen. Then at the bottom we have hydrogen on one side, hydrogen on the other side. But if we look to the third atom, here we have hydrogen in this case, in case of methyl, but if we look at the third atom, here we have hydrogen in case of methyl, but on the other side we have methyl group because it is the ethyl molecule, CH2 CH3. So we have one extra methyl group over here, and because of that, since this group is hydrogen while here we have ethyl group, it is having higher atomic number, and therefore it will be given the higher priority order number. I'll put a arrow, I'll put a symbol which shows that this group, ethyl group, will be given priority over the methyl group. And in certain cases, as in the previous slide we have also seen, that there may be more number of similar atoms. As I said, that methyl will be getting lower priority number as compared to ethyl. Similarly, if we have a propyl group, this propyl group will be given higher priority than ethyl group. So if in a molecule of containing a chiral carbon we have CH3 on one side, we have C2H5 on the other side, and we have C3H7 also along with the hydrogen atom. So all the groups are different. So this is a chiral carbon. So when we assign priority order number, we will give 1 to propyl group, then 2 to ethyl group, then 3 to our methyl group, and then 4 to the hydrogen group. In this way, groups will be priority order priority order numbers will be assigned. Now another case. So in this way, priority order numbers will be assigned. Now another example for you. In case of groups containing CC single bond on one side, for example, if this is a chiral carbon, we have CC single bond group attached with a CC single bond. For example, we have CH2, CH3, they contain CC single bond on one side. Other side we have CH double bond CH2, alkene, alkynyl group, and on third side we have C triple bond CH alkynyl, and then we have hydrogen. So in all the cases we have two carbons. Here also we have two carbons, here also we have two carbons, and here also we have two carbons. But while giving priority, CC single bond will be considered that carbon attached to one carbon, but in case of CC double bond, it is considered as carbon attached to two different carbons. Therefore, atomic number will be higher as compared to this one, because here it is connected to one carbon only. And similarly, CC triple bond means a carbon is connected to three different carbon atoms, and therefore it is having the highest atomic number, and it will be given the highest priority order number as well. So in this particular case, we will assign priority order number 1 here, priority order number 2 to alkynyl, and then priority order number 3 to ethyl group, and then 4 to hydrogen, and then we'll draw arrow from 1, 2 and 3 to identify its configuration. So this is another rule that would definitely help you, because most of the time questions are not very simple, and in competitions questions contains most of the time CC double bond or CC triple bond, or in some cases they have same types of group connected, so that you can have to look for the second and third atom of the substituent group to identify which group will be given priority order number 1 and which will be given lower priority. After doing all these things, we have to, after assigning, or as per the rule 1, 2 and 3, we'll assign priority order number. For example, as in this case, we got priority order number 1, then oxygen, then methyl, and then hydrogen. Then we'll draw a arrow from 1, 2 and 3 as it is shown in this example. 1, 2 and 3, the arrow is going like this, and since it is a clockwise direction, we can say that it is R configuration. If it is clockwise, it is R rectus, and if it is counterclockwise or anti-clockwise, it is S, means sinister. Let us see few more interesting examples. And rule 4 helps us to solve these questions. As I said before, if hydrogen is connected to the chiral center, it should always be given priority order number 4. Why? Because hydrogen is having the lowest atomic number, so if it is present, it is always assigned priority order number 4. But as I said, that the priority order number 4 should always be in such a way that it is going away from the viewer. Now remember these 4 points. Horizontal lines here represents the group pointing towards the viewer. So if any group is present on the horizontal line, it means that that group is coming towards us, while vertical lines are pointing away from the viewer. So if any group or atom is connected through a vertical line, this is a vertical line and this is a horizontal line. So if it is connected through a vertical line, it means that it is going away from the viewer. Similarly, a dotted line, I hope you all must be aware of it, that a dotted line represents a group or atom moving away from the viewer, while a strong line, wedged line, is considered as the group is coming towards us. So according to that, in this example, if I assign priority order number group, so OH is connected through oxygen, which is having the highest atomic number, so it will be given priority order number 1, followed by COOH, then we'll give priority to methyl, and hydrogen will be the last. And since hydrogen is on the vertical line, this line and vertical lines means the group is pointing away from the viewer. So group 4, hydrogen is pointing away from the viewer, and rule also says that while assigning RNS configuration, the lowest priority group should be moving away from the viewer. So in this case, the lowest priority group is moving away from the viewer. So we draw a line 1, 2 and 3, and since this line is again clockwise, So we assign it as, since it is clockwise, so we call it as R configuration. But look at this example. This is a very interesting example because here hydrogen is placed on the horizontal line, and horizontal line means that the group is coming towards us. Now when we assign priority order numbers, here this group CH2 is like this. C is connected to H, H and then OH. While in this case C is connected through double bond to H. C is connected with double bond to O and then with single bond to H. C double bond O means C is connected to two oxygen atoms. It is considered as, therefore it will be given a higher priority as compared to CH2. So our first priority will go to OH because it is connected through oxygen atom which is having a higher atomic number. Then among CHO and CH2OH, CHO will be given higher priority number 2, CH2OH will be given 3, and last is 4 will be given to hydrogen atom. Now in this case, since hydrogen atom which is on horizontal line means it is coming towards us, so when we draw 1, 2 and 3, the arrow is counterclockwise. Counterclockwise, this is S configuration. But since hydrogen is on the horizontal line, we'll give, instead of S, we revert this configuration and give R as answer. So whenever the lowest priority group, hydrogen or maybe any other group which is having the lowest priority is on the horizontal line, this line which is horizontal lines, if the configuration is S, we will give R as answer, and if the configuration is R, we will give S as answer. This is the case. Now let us see the, so if it is S, we will assign R, and if it is R, we will assign S as answer. Now let us see another interesting example. In this case, for example, here to the chiral carbon, two groups are attached through normal straight lines, while Br is attached through wedged line and hydrogen is attached to dotted line, and dotted line means the group is going away. So if we give priority order number, 1 will be given to bromine, then fluorine, fluorine, and then hydrogen. If we draw an arrow, it will be like this. So this arrow shows that it is a clockwise direction. If this arrow shows that it is a clockwise direction, we will assign R. No problem in this molecule. But look at the other molecule. In this molecule, look at this molecule. In this second molecule, since fluorine is going away from the viewer while hydrogen is attached to a wedge line, which means it is coming towards us, so we will rotate this molecule through this axis. We will rotate this molecule through this axis, this carbon and Cl axis, by 120 degree. When we rotate it by 120 degree, the molecule will assume another orientation in which the Cl, because we have rotated it, this molecule through C and Cl bond axis, this axis, because we have rotated this molecule through CCl axis, so it will remain in this particular form only, while rest of the group which are present at the bottom, they will shift through 120 degree angle. So since earlier bromine was with a normal line, by rotation of 120 degree it will come over here. Hydrogen from the wedged line, it will move backward with 120 degree angles, so it will now pointing away from the viewer. So we'll show it with the help of dotted line. And fluorine from here, it will move towards the bromine side and it will be shown like this. Now this is the new orientation, and now we'll assign priority order number. Again, bromine will be number 1. So bromine will be number 1, 2 will be given to Cl, then we have 3 for fluorine, and hydrogen will be 4. And now as we are following the rules, and rule says that priority order number 4 should be away from the viewer, and rule says that priority order number 4 should move away from the viewer, and since hydrogen is represented through a dotted line, it means that it is pointing away from the viewer, it is pointing away from us. So again we will follow the rule. We draw a line 1, 2 and 3 and check its direction. So we'll start with 1, 2 and 3, and this line 1, 2 and 3 is anti-clockwise. It is in this case anti-clockwise, so we'll assign it S configuration, and here we're not going to change the configuration. In case of straight lines only, horizontal vertical lines, we'll first assign number, draw the arrow, and then we'll revert the answer. If it is S, we'll give R. If it is R, we'll give S. But in this case, since we have already rotated the molecule before assigning priority order number, therefore we are not going to change the actual configuration. So we'll the configuration which is obtained from the new structure of the molecule, this is the final configuration. So sometimes you may be given questions in this particular form or in this particular form, and I'm sure that with this video you have got the concept of RNS configuration and you have seen few interesting examples, so you would be able to solve questions in your competitive exams.